Welcome to Cooking with Chemistry with your three special super celebrity guest hosts,
James,
Ethan,
and myself, Finn. Today here in Redondo Beach, California, we will be conducting a massive experiment to solve this super top secret chemical formula to derive a delicious baked good. Really, we'll be following this recipe from my dad's banana bread, which actually involves a lot of chemistry and it will really taste good.
the process of cooking is a series of chemical reactions that turn separate ingredients into a cohesive, edible dish. Baking might not seem like it involves chemistry, but the ingredients we use will undergo chemical changes to form the final baked good. The main ingredient you need for banana bread is, wait for it, bananas! What you really want is a super ripe banana. How can you tell if a banana is ripe and ready for banana bread? It is soft, mushy, and mostly black. Ew, gross. Why do bananas turn black anyway? The skin of the banana contains a gaseous plant hormone, ethylene, which diffuses into a fruit and hastens the process of ripening. When the fruit comes into contact with ethanol gas, the acids in the fruit start to break down in a chemical reaction. It is yellow when the fruit is ripe, but it will eventually over-ripen and turn black by producing too much of its own ethylene. But enough about fruit.
Our baking process starts with 10 different ingredients, including bananas, which will ultimately end up in a homogeneous mixture we call banana bread. The first step will involve mixing sugar, margarine, and eggs together. The margarine we use comes in a solid stick form, so we'll have to perform a phase change by applying energy from microwaves to melt the margarine. Solid goes in, add some heat, liquid comes out. The sugar does much more than just sweeten a cake. When the baking temperature reaches above 300 degrees Fahrenheit, sugar undergoes what is known as a Maillard reaction, a chemical reaction between amino acids, protein, and reducing sugars. The result is browning, which forms the crust of many baked goods, such as banana bread. Eggs in a mixture fulfill important functions. Beaten egg white is used to give the batter a light, fluffy consistency. This is possible because egg whites contain a protein that coats the air bubbles created during beating, which stops the cake from sinking during baking. Employing principles contained in the combined gas laws, whereas the temperature increases, the volume increases. It also acts as a binder to hold the bread together. Next, we'll add leavening agents, baking powder and baking soda. Leavening agents will give back baked dough its lightness. Baking soda, a base, reacts with acids in the batter to make carbon dioxide, which helps the bread to rise. Baking powder, which is baking soda, will, with an additional acidic salt, releases carbon dioxide twice during the baking process. Once when it hits water and again when it reaches a certain temperature in the oven, associated with its activation energy. Heat helps baking powder produce tiny bubbles of carbon dioxide, which make the bread light and fluffy.
Next we add milk, flour, and bananas. Most baking is based on the use of flour, the powder from the grains, nuts, and beans. Wheat flour, used in our banana bread, is composed largely of starch and protein with very high levels of class protein known collectively as gluten. When water, or in this case, milk, is added to wheat flour, the gluten forms a heavy, pliable mass. This expands greatly under hot temperatures, undergoes state change from liquid to solid, and sets with the desired airy texture. Now we are ready to pour batter into a baking pan and toss it into a preheated oven at 375 degrees Fahrenheit. That's about 190 degrees Celsius. We have some choices here. If we use a long, wide, flat, rectangular baking pan, we increase the surface area of the batter exposed to the oven's heat, which increases the reaction rate, and the banana bread cooks in about 55 minutes. Instead, we chose a more compact baking pan having less surface area, and it takes about 70 minutes to cook, but the banana bread comes out much moister. We also increase the temperature, but we could end up burning the bread due to the characteristic heat transfer rate of the batter. 375 degrees for 70 minutes, and it is.
we wait to cook. Now it's done. Due to the specific heat capacity of banana bread, it takes about 30 minutes for enough heat to transfer to take place so that it cools down enough to eat. But before we dig in, one more part of chemistry, a combustion reaction. Fuel plus oxygen leads to heat, light, carbon dioxide, and water as we celebrate the end of school and this video. See ya.